Right, welcome back the second hour. Okay, I'm going to learn first for the Gmeet recording. What uh, special character of Gmeet? Maybe I'm going to search first how to record that one because recording is important. Some of you maybe have difficulty in connection, not only because of the Zoom, maybe because of the any other things like unstable connection. So maybe I can give you the record. In Zoom is automatically record, but in Gmeet I have to learn first. Okay. Now let's continue in solving some example of the lowering vapor pressure. All right. Let's start with question number 1, example 1. All right. The question is the vapor pressure of water at 100 degrees Celsius is 760 millimeter mercury. Calculate the vapor pressure of 18% glucose solution by mass. Okay, if you have unstable connection, you can turn off your camera. If you got the answer, please write down in the chat column. Okay, one student answer already. Lutfi, thank you very much, Lutfi. Your answer is true. Vishnu, try it again. Alfia Nur, thank you. Okay, Hambali. Come on. Baru satu, dua, baru dua orang yang menjawab. Denny, try it again. Ya, ada masih banyak yang salah ya. Iki, try it again. How do you get that number? Denny, thank you. Now it's true. Daud, try it again. But it's near to the answer. Maybe some wrong calculation, Daud. Vishnu, yes, thank you. All right. The others. Come on. A simple question, yeah. This question number one. It is not a trick actually in here. You learn how to convert the percent into the more fraction. We learned from last week. All right, I think no one can give us again the answer. Let's solve together this question. Now this question is telling you it is 18% of glucose. So 18% of glucose, it's mean that if I have 18 gram of glucose, then in the 100% solution, 100 gram solution, isn't it? So from here, I get the mass of glucose is 18 gram, and the mass of water, I can calculate 100, the mass of solution, minus 18, I'll get 82 gram of water. From here, I can find the mole of glucose, which is equal to the mass of glucose divided by mR. The mass of glucose is 18 gram, and the mR of glucose is C6H12O6. When you calculate this one, the mR will be 180, isn't it? So I can put here 180, so I got 0.1 mole of glucose. How about mole of water? Mole of water is equal to mass of water divided by mR. Mass of water is 82 divided by mR is 18, the mR of water. When you calculate this one, you will get 4.55 mole. Yeah. From here, I can calculate the mole fraction of water. Let's calculate the mole fraction of water. Mole fraction of water is equal to mole of water divided by mole of water plus mole of glucose is equal to 4.55 divided by 4.55 plus 0.1. I keep this one as a mole fraction of water. Now the question is, calculate the water pressure of glucose solution, isn't it? Vapor pressure of glucose solution. So actually I can use this formula. P solution, P glucose, P glucose solution, P glucose solution is equal to mole fraction of solvent, which is water, time P0 of solvent, which is water. So from here, I get P glucose is equal to mole fraction of water is this 4.55 divided by 4.55 plus 0.1. Let's put parenthesis here. This is the mole fraction of water time the P0 of water. P0 of water is given here. The vapor pressure of water at 100 degrees is this one. So this is P0 is 760. Yeah. When you calculate this one, you will get that 743.67 millimeter mercury. So this is the P glucose. As you can see, P glucose will be lower than pure water. Pure water is 760. Glucose is 743.67. It's lowering. Okay, is it clear? Do you have any question? Ini formula yang pertama apa yang kedua yang saya pakai nih?
First.
The first one. Good. This is the first formula that we use. Very good. Can I clear it? Yes, you get the answer. All right, now another example. The vapor pressure of water at 5 degrees Celsius is 23.76 millimeter mercury. At the same temperature, at the same temperature, urea solution has vapor pressure 23.16 millimeter mercury. Calculate the lowering vapor pressure. The lowering vapor pressure in urea solution. Okay, please. Vishnu directly answered. Thank you, Vishnu. And your answer is true. Very simple question, isn't it, Vishnu? If you are understand already the concept, it is a very, very simple question. Thank you, Vishnu. Alfianur, thank you. Don't be confused, Alfianur. Your answer is true. Daud, thank you. All right, the others, and come on, guys, a very simple question. Sauki, thank you. Don't be confused. Iki, thank you very much. Very good. All right, Musa, thank you. You understood already, I think, the question. It's a very simple question. The question is called the lowering vapor pressure, delta P. You're going to put that the formula that from the beginning, yeah, the basic formula of delta P. Delta P is actually is the lowering of the solution when you compare with the pure. So P0 solution, not P0, sorry. P solution, ya, minus, oh terbalik ya, sorry, the lowering, ya, the lowering. So it is P0 solvent minus P solution, isn't it? P0 solvent, which one is solvent? Solvent is water. P0 is this one, 23.76 minus P solution. What is the solution? Urea solution here. And the vapor pressure is this one, 23.16. So it is very simple. You will get the answer 0.6 millimeter mercury as the answer. If you understand already the concept of what is delta P from the explanation before, you will be very simple to get the answer for this question. Can I clear? All right, thank you. Okay, let's do another example. Another example. The vapor pressure of water at 29 degrees Celsius is 30 millimeter mercury. At the same temperature, calculate. I have two questions, two parts. Part A, vapor pressure of, calculate the vapor pressure of 20% urea solution by mass, and given that mR urea is 60. This is the first question. And question 2, what is the vapor pressure of the same urea solution, but now is given as 1 molar urea solution. So two different questions. Let's solve. Let's start from A first. If you got the answer for part A, please write down the answer in chat column. All right. I see some answer here. Lutfi, thank you very much, Lutfi. Your answer is true for part A. You can continue part B. Daud, thank you. Continue part B. Iki, continue part B. Yogi, continue part B. Sauki, continue part B. Naufal, continue part B. Andika, continue. Mursid, different answer. Please calculate again. Ramadhani, calculate again, please. Danny, thank you. Continue part B. All right, I guess some answer here. Most of you are true. Alfie, both of them already. Thank you, Alfie. Both of them are true. Vishnu, part A, yes. All right, let me answer for part A first. Okay, for part A, now we got 20% solution of urea by mass. So we got 20%, it's mean that 20 gram urea in 100 gram solution. Okay, so mass of urea I got 20 gram. Mass of water I got 100 minus 20, it got 80 gram. Okay, then mole of urea is equal to mass of urea divided by mr. So mass of urea is 20 over 60 is 1 over 3 or 0.33. The mole of water is equal to mass of water divided by mr. It is 80 divided by 18, and you got is 4.4. 4.4. And then I'm going to find the mole fraction of water. Mole fraction of water is equal to mole of water divided by mole of water plus mole of urea is equal to 4.4 divided by 4.4 plus 0.33. If you calculate this one, you will get 0.93. So the last one, we're going to put the formula. P is equal to X solvent, isn't it? Time P0 solvent. Because the question is vapor pressure of urea solution. So it is the P, not the delta P. The question is the P. So you can use this formula, X solvent time P0 solvent. X solvent is already, we found here, which is the X of the water, 0.93 time P0 solvent. P0 solvent is 30. So when you calculate this one, you will get 27.9 millimeter mercury is the answer. Is it clear? Okay. Can I erase for part A? Right. I think you write down the answer, yeah, and we're going to see the solution for part B. All right, let's see from the chat. Part B. Vishnu true. Lutfi part B still not true. Denny part B, yes, thank you. Lutfi part B, thank you. Iki, calculate again. Okay, Still waiting for the answer for part B. Sauki, part B, thank you. Andika, yes, thank you, Andika. Your answer is true. Very good. Not the most of you, yes, some of you already answered truly for part B. Let's do it together, part B. Again, this is the equation of Weber pressure of 1 molar urea. So again, we're going to use the same formula, yeah. P is equal to X solvent times P0 solvent. So we have to find the X solvent here. Now it is given molar. So we are going to change the molar into mole fraction. So part B, 1 molar, we have to convert it into mole fraction. We know that molar is equal to mole per P. If I'm using this one, P will be what? In kilogram or in gram? If I'm using this formula.
Kilogram.
In kilogram. So if I say that 1 molar urea here, then it will be 1 mole urea. Sorry, let me. 1 molar is equal to N per P. So if I say that 1 mole urea, it means that 1 mole urea over 1 mole urea over 1 kilogram of water, isn't it? Because P in kilogram is P of solvent in molar, remember. So I get this one, 1 mole urea and 1 kilogram of water. So from here I can get mole of urea is equal to 1 mole, because it is 1 mole of urea. Mole of water is equal to mass of water divided by mR. Mass of water is 1 kilogram. We convert it into gram. It is 1000 gram over mR of water is 18. Yeah. When you calculate this one, 1000 over 18, you get 55.56. This is the mole of water. And the mole of urea we got is 1 mole of urea. All right. And then let's continue to find the X water, yeah, because we need X solvent. X water is equal to mole of water divided by mole of water plus mole of urea. Mole of water is 55.56 over 55.56 plus 1. From here, what you got? 0.98 as the what we say that is an mole fraction of water. So the P of urea solution will be equal to X water times P0 of water. Yeah, according to this formula, the solvent is water. So X water is 0.98 and P0 of water is the same, it is 30. Is 30. When you calculate this one, 0.8 times 30, you will get 29.47 Sorry, at the last, yeah, I lost my connection, but the answer is 29.47 millimeter mercury. Okay. Is it clear, guys? All right. So I think we don't have much time, yeah. All right. Let's stop in here for this meeting. And the time is also already finished. In the next week, we are going to learn about the freezing point and boiling point elevation. Yeah. And then after that, if we still have time, maybe we're going to also do the osmotic pressure. And the following weeks after that week, maybe we're going to finish this chapter. And after that, we are going to have a unit test, of course, after we finish the test. Okay, that's enough for today. See you next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi
wabarakatuh.
Thank you, sir.
Welcome.
Thank you, Mr.
Thank you, sir.
See you again.